Hi, I'm Mike Rowan, one of the co-hosts of the CoCo Crew podcast. Welcome to a new video series entitled Retro Printing for Fun and Profit, sharing new and old printers with new and old computers. At a high level, we're going to address two primary goals. First, we're going to turn a retro dot matrix printer into a functioning Wi-Fi network printer. Second, we're going to enable the Tandy color computer to print to both new and old printers on a Wi-Fi network. This series is part hardware, part software, part RS-232, part Raspberry Pi, part color computer, and of course, lots of paper. Alright, the printer that I'm going to be working with is the Tandy DMP-130. It was introduced in 1986 with a list price of $349.95. It has a near letter quality mode, as well as the data processing mode and dot addressable graphics mode. It could also do IBM Pro Printer emulation. So it was a pretty handy printer for its time. And at 10¼ pounds, it won't be moving around on your desk either. These things were built like tanks. You could use a single sheet feeder, which I don't have here, but you could have a single sheet feeder, or you can use the detachable tractor feed for continuous feed paper. Pops right off. On the back, you will find that you could connect using a Centronics parallel or the 4-pin RS-232 serial port, which is what the color computer uses, which was a nice feature for the color computer back in the day. There are dip switches where you could set options, such as whether it's in parallel or serial mode. You could set the bit rate of the serial port, which topped out at 2400 bits per second, which was pretty smoking for 1986, and various other Pro Printer emulation, new line, carriage return options. Now, believe it or not, you can still get ribbons for the DMP-130. It uses a ribbon cartridge, and these are readily available. In fact, this same cartridge will work with the DMP-130, the 130A, the 132, the 133, the 136, and the 107. And I believe that there are still printer ribbons available for most of the 200 and 400 series Tandy printers. So if you've got an old dot matrix printer, an old Tandy printer, you shouldn't have great difficulty finding a ribbon for it. In this project, we're going to be interfacing the DMP-130 and the TRS-80 color computer to a Raspberry Pi. This will allow modern PCs to print to the DMP-130 on the Wi-Fi network, and will also allow the TRS-80 color computer to print to modern laser printers on the Wi-Fi network. But before we go down that road and start working with the Raspberry Pi, it's important for us to understand what the original design intent was and how printing works between the TRS-80 color computer and the DMP-130. The color computer has a built-in RS-232C serial interface. It's well marked on the back of the CoCo. It uses a 4-pin DIN receptacle. It's the same on the CoCo 1, 2, and 3, and even the MC10. Also note that the connector key is located at the top of the port on all CoCos. This makes it easier to orient the cables from the top side. Looking at a CoCo, the pins are numbered 1 through 4 in a clockwise direction. You can find a full description of the serial port in the Radio Shack TRS-80 Color Computer Technical Reference Manual. Pin 1 is a status input line, presumably meant to be carrier detect. It's an input to the CoCo from an external device. Pin 2 is RS-232 in serial data input. This is for data from an external device to the CoCo. Pin 3 is ground. Pin 4 is RS-232 out, serial data out. This is an output from the CoCo to an external device. Now let's look at the serial port on the DMP-130 printer. It's the same type of 4-pin DIN connector that's found on the CoCo, but it's positioned so that the key is at the bottom. The DMP-130 operations manual doesn't have a diagram of the connector, but it does provide a table describing each pin. Pin 1 is not used. So if you're building your own cable, you only need 3 wires instead of 4. Pin 2 is described as the status. This is an output from the printer. Pin 3 is ground. And pin 4 is simply called data. This is an input to the printer. So let's take a look at how the printer and the CoCo communicate over these ports. The signals of the printer and the CoCo are complementary, meaning that an output on the CoCo is an input on the printer and vice versa. This means that you connect the CoCo and the printer using a straight-through cable. Pin 2 is the status line, and it's an output from the printer, and it's connected to the CoCo's RS-232 in. Pin 3 is ground on both ends, so pin 3 on the printer is connected to pin 3 on the CoCo. And finally, pin 4 is the RS-232 out from the CoCo to pin 4 data in on the printer. The Radio Shack cable has pin 1 connected to pin 1, but as we saw, the printer does not use pin 1. So we've established how you connect the printer and the CoCo. Let's look at the purpose of the status line from the printer. When the printer is online, it means it's ready to receive data. It signals this by bringing pin 2 high. Whenever the CoCo is going to print something, the status line must be high before data can be transmitted to the printer. When the printer is offline, it isn't ready to receive data. It signals this by bringing pin 2 low. The CoCo can't transmit data while the status line is low. Have you ever typed LList on a CoCo without anything plugged into the serial port? The CoCo just sits there, waiting for pin 2 to go high. It'll wait forever. In fact, the only way out of it is to press the reset button on the CoCo to get back to a prompt. Now let's take a closer look at the status and RS-232 out signal working together. The printer is online, so the printer sets the status line high to tell the CoCo it's ready to receive data. When you type the command LList, this will allow the CoCo to transmit data over pin 4 to the printer. But if the printer goes offline, the printer will bring the status line low, and the CoCo stops sending data to the printer. And the CoCo can't resume sending data until the printer brings the status line high again. This stop-and-go logic is called flow control, and it's necessary to prevent data from being lost while the printer is printing. The CoCo can hold all of its data in memory, but the printer has a very small buffer to hold incoming data, and the printer can't print data as fast as it receives the data. So, it controls the flow of the incoming data by raising and lowering the status line as needed. So what kind of things can make the printer go offline? Well, there are a number of physical reasons that it might go offline. The printer is powered off. So if someone accidentally comes up and kicks the plug out of the outlet, the printer will power off, the status line will go low, and the CoCo will halt sending any data. Someone could accidentally hit the power switch. A breaker could blow. The printer is out of paper. If the printer runs out of paper, it will beep and it will set the printer offline. That'll stop the CoCo from sending data until you correct the issue. You could load some more paper, you press the online button, and printing would resume. The on-offline button is pressed. On the front panel of the DMP-130, there's an online-offline button. You can, at any time while it's printing, press that button to halt the printer. That'll take the printer offline. The CoCo will stop sending data so that you can service the printer. Say, for example, that you need to change the ribbon in the printer. You could stop the printer, pull the ribbon cartridge out, put a fresh one in, press the online button, and printing would resume. The serial cable is disconnected. If for any reason one end of the serial cable gets unplugged, the printer will go offline because the color computer can't receive that signal anymore. And there are a few software reasons as well. One of them is that the firmware isn't very smart in the printer, but it should be able to detect things like a paper jam blocking the carriage from returning to the position it expects. In that case, it would take itself offline and beep to alert you that there's a problem. But the most popular reason that the printer is offline is that the printer's buffer is full. The printer has a very small buffer space, and there's no way that the printer can print at the same speed it's receiving data. So periodically, it must tell the color computer to halt data transmission until it's processed the data that's in the buffer. So let's take a little closer look at flow control. We see here the memory of the color computer. The blue represents the data we want to send to the printer with the list command. On the left, we see the printer's empty buffer memory, where it holds incoming serial data. You can see the status line on pin 2 is green, meaning that it's high or online. And the data line on pin 4 is poised for data transmission. So we go to our color computer, we type list, and we hit the enter key. The printer will start printing, and data is sent from the CoCo to the printer. Now watch the printer buffer memory. It's going to hit a certain threshold where it's full and can't receive any more data. So it's going to set the status pin low to tell the CoCo, stop sending me data. The printer will continue to print, but it's printing from its buffer. And once that buffer has been emptied, it will return the status line high, telling the CoCo that it's ready for more data. This stop and go process repeats until all of the data from the CoCo has been sent to the printer. So we now have a good understanding of how to print from a CoCo to the DMP-130. But what if I want to also print to the printer from a modern computer? Or what if I want to be able to send program listings from the CoCo to my laser printer? How can we make all of those things happen? By using the Swiss Army knife of computing, the Raspberry Pi. So in the next video, we're going to interface a DMP-130 printer to a Raspberry Pi and print to it from a modern computer. So until then, thanks for watching, and we'll see you in part 2.